So our next speaker is going to be Adam Atkinson, talking about biggest, best, and contrast between them, perhaps. I don't know. Never know what Adam's going to say. So handing over to Adam.
Okay, I hope everybody can hear me. Whoops. Right, I'm Adam Atkinson from the ELHP, and today's topic is one of the biggest, always best? And to skip straight to the executive summary, the answer is no. Here is my open day table at Pisa University with some stuff on it, and here are some of my victims. And this is not a problem I ask at Pisa University Open Day, but at least once a year, somebody seems to think I have asked them. And I don't understand why this is, but let's talk about the non-open day problem today. I give you a heap of n tokens. You can split it into as many sub-heaps as you like, but all of their sizes have to be distinct prime numbers. I will then multiply all the sizes together and give you the product in British pounds. The question is, how do you maximize the amount I have to pay you? You can't do some numbers. 1, 4, and 6 are impossible, and no others are. 0 is possible. It's the sum of no primes with a product of 1, but that's a bit silly. Let's look at an introductory example, 11. Here are all the ways I can split 11 into distinct primes. 11. How many primes is that? It's 1. What's their product? 11. You might think that's a silly example, so let's go with something slightly less silly. With 10, you have two options. You can split it into 2 primes with a product of 21 or 3 with a product of 30. So the one with 3 primes is biggest because it's got 3 primes in it, and it's best because it's got the highest product. So in this occasion, biggest is best. Let's try it with 20. And for brevity, let's call them bigosity and bestitude. With 20, there are 2 options with 3 primes. So there are 2 biggest ones, but one of those is best. So again, one of the biggest is best. Let's try 30. There's one with 5, that's the biggest, and it also has the highest product. So biggest is best again. What about 40? Well, here we've got quite a lot of options. There's 3 with 5 primes. One of those is the biggest. So one of the biggest is best. Again, the question at this point is, does this happen forever? And the answer is no. N equals 319. The split with the highest number of primes in it does not have the highest product. And if we go looking for examples, we can find some here. And we notice that the best split in all of these examples has 1 fewer prime in it than the split with the highest number of primes. Here are some more values that I found by writing a computer program and looking for them. So up to 28,000 and something. A friend of mine, if I remember correctly, has gone up to about 1 million. And all of the examples I'm aware of have a difference of 1 between the size of the best split and the size of the biggest split. So there are various questions. Do these examples continue forever with a difference between biggest and best? Can the best split be too smaller than the biggest? I haven't found any, but maybe it can. And can the best split be k smaller than the biggest for general k? And that's it. Thank you very much.
Oh, that's rather intriguing. Yeah, I like that. Everybody, it's something where it's related actually to one of the puzzles in the puzzle maths room. For those of you who have been doing some of the puzzles, when checking the leaderboard, some of you I know have. There's one of the puzzles there that's vaguely related to that, and it's nice to see it turning up as an unsolved problem with a question that pretty much anybody can understand with a little bit of noodling around. That's lovely. So